All right, so today we want to learn to solve the ordinary first order variable coefficient linear equation as depicted in the first line. P is a coefficient, Q is a coefficient. They might be functions of x or they might be constants. So to do this, we first find what's called the integrating factor, mu of x, defined on the screen. Then we form mu times the equation. So you multiply both sides of the equation by mu. If you have the right mu, if you've calculated that correctly, then the equation on the left-hand side should be the derivative of a product, namely the derivative of mu times y, where y is the solution. So we go through and multiply. First you multiply by both sides by mu, then you show that it's the derivative of a product, and that can be checked. It's probably a good idea to check that just to be sure you're on the right track, because if that doesn't work, then you have to go back and recalculate mu. At any rate, we have then the integral of the differential of mu times y. And if we have the right mu, then this should be the integral of the differential of mu times y. In other words, the integral of the derivative of mu times y. So the integral of the derivative will give us just mu times y, as seen on the screen. And then if I integrate both sides of this, I get y by it standing by itself, and then divide by mu, and I get y equals 1 over mu times the integral, plus the constant times the integral. That c is the constant of integration. So now the next thing we're going to do is an example of this calculation methodology for a standard, sort of a typical equation, shown here on the screen. T times x dt plus 2x of t equals 4t squared. So the first thing we do is rewrite the equation in the standard form so that we can find p of t. And here I see that p of t is equal to 2 over t. So I could calculate mu from that and then multiply both sides of the equation by this mu. Notice mu is t squared, so I multiply both sides of the equation by t squared. That gives me then, on the left-hand side, a derivative of a product, and then another term on the right-hand side. So if I multiply both sides by dt, I get the differential of t squared times x equals something. Then I integrate both sides. So if I've done this correctly, I'm integrating the derivative, so I should get the object that was differentiated, namely t squared x of t. And then in this case, it's equal to t squared x of t is t to the fourth plus a constant of integration. So I could solve that line for x by multiplying both sides by 1 over t squared. So if I do that, I get then x equals t squared plus c over t squared, which is the solution, where c is the constant of integration. Now, some observations. You'll notice I get one constant of integration. That's because the original equation was of first order. And I get 2 terms in that because the way the integration turned out. Now note also that the original equation is a linear equation in x. So what I've done is I've used that method that I had before, in the slide before, to solve this equation for x of t, using this integrating factor, mu of t.